Okay, so in this problem, we have a bat and a moth, and they're both of them are flying towards each other. So this is a problem where source and observer both of them are moving, but the difference here is the catch of this problem is there will be two different Doppler shifts, because when the bat is emitting some sound wave, moth will be the observer, and so the moth so the when the frequency reaches towards the moth, it will change, and then it will reflect back. So when it's reflecting back, then the bat is becoming the observer and the moth is the source. And again, since they're moving towards each other, so the frequency will change. So yeah, so we're having two Doppler shifts. One is the emitted sound when the bat is the source and moth is the observer, and for the reflected sound when the bat is the observer and moth is the source. So let's write the equations for that. So we're using equation 12.4, and if we use that, we'll have, so this is for the so the blue one is the emitted and the green one is the reflected. So this is for the emitted part where moth is the observer. So that's emitted. So frequency received by moth will be frequency generated by bat, and then speed of sound plus speed of the moth divided by speed of sound minus the velocity or speed of the source, which is the bat for our case. And then for the reflected case, we'll have bat frequency observed by bat, that's equal to frequency that's emitted from moth. So since the frequency has changed now, so this will be our source, and then speed of sound plus velocity of the observer divided by speed of sound minus velocity of the source. Right. So if we combine these two equations, we know that we can substitute this guy over here, and then we'll get frequency from the bat while it was emitting times speed of sound plus velocity of moth divided by speed of sound, velocity of the bat, and then we'll have this term, which is speed of sound plus velocity of the bat and speed of sound minus velocity of the moth. Right, so now if we plug in all the numbers, we'll see so the frequency is given as 51.38 kilohertz. So that's gonna be 51.35 kilohertz. Then we'll have 343, that's the speed of sound, velocity of the moth, speed of sound, velocity of the bat, and then we'll write this expression, we'll put the numbers. It's gonna be this, divided by 343 minus 5. And if we do that, we'll get 55.3 kilohertz. So that's what the bat will receive after it reflects off the moth. Thank you.